Hello ladies, it's Mr. Sullivan. Today we're going to be looking at lesson 9-4, using trig to find a missing side length. Today's learning target is I can apply SOHCAHTOA by using a triangle to find missing side length. So here's going to be our procedure. As we go through the procedure, we're actually going to execute it on this problem over here, and this is our side length. Remember, side lengths are on the outside of our triangles, the inside of our triangles are our angles. The directions say find x to the nearest hundredth. So we're going to go out 2 decimal places, okay? 10th, 100th. So step 1 says identify your reference angle. Just a heads up, for these questions, your reference angle is simply the angle in your image, and it's never your right angle. So in this question, my reference angle is going to be 42 degrees. So if you want, you can go to the outside and write down reference angle 42 degrees. Step 2, label your sides as hypotenuse, opposite, and adjacent. And I would do it in that order. So I would always start with my hypotenuse because it's across from my right angle. So if I look across my right angle is 18, so I have my hypotenuse. Then I label my opposite. And my opposite is across my reference angle. In this case, it's x. And then last but not least, I write my adjacent. Step 3 says choose your trig function. So basically, you need to figure out what do you have information about. I have SOHCAHTOA, so I'm going to write down SOHCAHTOA on the outside of my image. If you look, I have information about my opposite, and I have information about my hypotenuse. So when I'm dealing with opposite and hypotenuse, I'm dealing with sine of theta. So the first thing we do is we're now going to solve for x. So we can say sine of 42 is equal to the opposite over the hypotenuse. We can then say sine of 42 is equal to x, because that's our opposite, over our hypotenuse of 18. Now we're going to solve for x. This sine of 42 is really over 1. So what we're going to do is I'm just going to move this over here, that way there's more room. We're going to cross multiply. And when I cross multiply, 1 times x is x. And then I get 18 sine 42. So it's not sine of 42 times 18, it's 18 times the sine of 42. So remember, our calculator needs to be in degree mode. It's in degree mode. So I'm going to mode it. So now I'm going to type in 18 sine 42. Hit enter, and I get 12.044 something. I want to round to the nearest hundredth. So I'm going to go out 3 decimal places. So x equals 12.044. I want to round to the nearest hundredth. So I put a line in between my 4s. Look to the right. That 4 is smaller than a 5, so my final answer is just going to be 12.04. And that's how you find your missing side length. And that's going to be our procedure for each one. So next image, find x to the nearest 10th for these questions. We're going out 1 decimal place. Step 1 says identify your reference angle. In this case, my reference angle is 28 degrees. Step 2 says label your sides as hypotenuse, opposite, and adjacent. Well, we know x is my hypotenuse because it's across from the right angle. We know the sides are opposite because it's across from our reference angle. And then we have our adjacent, which is 6. So now we're already at step 3, where we have to figure out SOHCAHTOA. So SOHCAHTOA. I have information about my hypotenuse and my adjacent. So I am dealing with cosine of theta. So the first thing we're going to do is we're going to write down cosine of 28 is equal to adjacent over hypotenuse. Our adjacent is 6, so I have cosine of 28 equals 6. And my hypotenuse is x. And this cosine of 28 is really over 1. Now we're going to cross multiply to solve for x. 6 times 1 is 6. X times cosine of 28 is simply x cosine of 28. And that's equal to 6. Now, cosine of 28 is a number, so I can actually divide both sides of my equation by a cosine of 28. So we're going to divide by cosine 28, divided by cosine 28. So x is equal to 6 over cosine of 28. So I'm going to type that into my calculator. So alpha y equal enter. 6 over cosine 28. I'm going to hit enter. And I get 6.79. But the thing is, we want to round to the nearest tenth. Look to the right. That's a 9. So it becomes 6.8. And that's your final answer. Okay, let's go on to the next question. So I'm going to make this a little tinier. That way there's more room, because I've never done it on this app before. So question number 2, we want to solve for x. So we know what our reference angle is. Our reference angle is 63 degrees. Now we're going to label our sides. So we know that across from your right angle is your hypotenuse. Across from your reference angle is your opposite. And then last but not least, you have your adjacent. Now we're going to figure out SOHCAHTOA. So I have information about my adjacent and my opposite. So we're dealing with tangent of theta. So if we want to solve for x, we can say tan of 63 equals opposite over adjacent. We know our opposite is x, and our adjacent is 34. This tan of 63 is really over 1. Now I cross multiply, and I get x is equal to 34 tan 63. I type this into my calculator, hit enter, and I get 66.72. Round that number to the nearest tenth. Look to the right. That 7 stays the same. So I can say x is equal to 66.7. And that's your final answer. Time to make it tinier, because this next problem is going to take up a little bit of space. Okay. Now let's go on to this next problem. So in this problem, it says find the length of each side to the nearest tenth. So first thing we're going to do is we know what our reference angle is. Our reference angle is 30 degrees. So if you would like, we're going to make this our reference angle. Now we're going to label our sides. So 42 is my hypotenuse. This is my opposite. And this is my adjacent. So what I'm going to do is I actually want to solve for my opposite first. It doesn't really matter. I don't know what my opposite is, so I'm going to put an x there. So step 1, find opposite. So we know our opposites, so SOHCAHTOA. We have information about our opposite, and we have information about our hypotenuse. So I'm dealing with opposite and hypotenuse. I'm dealing with sine of theta. So I can say sine of theta, or sine of 30, is equal to opposite over hypotenuse. In this case, my opposite is x, so I can say sine of 30, remember that sine of 30 is over 1, is equal to x over my hypotenuse of 42. I cross multiply, and I get x is equal to 42 sine 30. I type that into my calculator. I hit enter, and I get 21. So I can say x is equal to 21. Now that I know x is 21, I can go to my image and just put a 21 in. Now, I want to find my adjacent. So I don't want to use x this time. I'm going to use y. So now step 2, find your adjacent. So we're going to find our adjacent. So in this case, if I look, I have information about a bunch of side lengths. I'm going to do cosine. I'm going to do cosine because I like dealing with cosine because that's my initials. If you look, I have information about my adjacent. I have information about my hypotenuse. So that means I'm dealing with cosine of theta. So I can say cosine of 30 equals adjacent over hypotenuse. If we look, our adjacent's y and our hypotenuse is 42. We cross multiply, so I get y equals 42 cosine 30. Type it in. And I get 36.37. Round to the nearest tenth, so that 3 becomes a 4. And that's it. Okay, so if you have any questions, email myself or Miss Calarundo. Have a great day, ladies.